haven't, Packrat, dependency management system bar, that probably sounds like a fairly dry topic, but I think it ends up being a pretty fundamentally important one because it goes to challenges around reproducible research, which is a lot of people are concerned with. There's general concern in science and the industry about can we rely on data analysis if we can't reproduce it. So there's a lot of that discussion has been in popular press, it's in science, and you can see sort of from the CRAN task view on reproducible research, it's something that we all aspire to be good analysts and good scientists. And that's really one of the fundamental things that this Packrat system that we'll talk about today is designed to address. And reproducibility has a couple dimensions. So one of them is across time. So I have created a data analysis, or I've created an SWE report, and I ran it today, and I want to know, can I run it again in a year, in 3 years, in 5 years? If the assumptions behind the analysis change, I run them again in a year, it isn't even going to work. Or if I do a study and later on someone's trying to validate or invalidate my work, can they reproduce things? So there's the time dimension of reproducibility, and then I'll call it the space dimension, which is I'm working on my desktop, I'm building a Shiny application or something that's going to run in a model that's going to run in production. Can I reproduce the conditions on my desktop on a server? Can I deploy things reliably? And of course, that also, across space, can also mean collaborators. There's 4 of us working on the project together. Are we all working in the same environment? And so I think in R, because of the nature of R, because you write code to do data analysis, we do pretty well compared to systems like Excel. But we don't do well enough, as I hope I'll explain better as the talk goes on. So if we think about the fundamental tools for reproducibility, the ones we probably think of most often, one is computation. Can we execute again and get the same results? That's actually a fundamental part of R. We write R scripts, so we don't point and click through a bunch of dialogues and we have no idea what we did, or we don't have an Excel spreadsheet which is like impermeable what's actually happening in the spreadsheet. We actually have a script, and so we have very good reproducibility of computation in R. Another dimension would be output. So if we've created a report, can we reproduce the report again? And again, we have pretty good tools. We have, how many folks here use either SWE or Knitter? So people know. This is a really powerful tool, and both SWE and Knitter are excellent tool sets. Reproducibility of output, we do well in R. But there's this configuration. So that's a whole other dimension because I have a code that runs, but it actually depends on a whole bunch of other code. It depends on, so let's say 15 packages. And I have versions of those 15 packages installed today. 2 years later, I go back, or I deploy my code to a server, or I go later, I update the packages, things start breaking, results are different. I can't reproduce things because I'm not able to easily mirror my configuration. And so this is a hard problem because mirroring configurations can be very painful and time-consuming. You can do it with a lot of effort and bother, so people by and large don't do it today. I misspelled configuration. I don't know how that happened. Didn't misspell it here. So this is what I call configuration rot, which is packages evolve, and at best they have subtle changes in behavior, which still can make the results of your analysis different. And at worst, they just break code. So I go back and, oh, error. I don't know why. Do I even have time to investigate? Am I even going to be able to overcome this error? And so if you write a report today, it's probably not going to work without modification in 5 years. If you go and install the same packages 5 years from now, it's probably going to break. So you're upgrading to R3.7, and you install all the fresh versions of all the packages that come with R3.7, your report probably isn't going to work. So, and we see this now in much less time than 5 years, that people write a paper, they'll have a SWE or Knitter document associated with it, and then it doesn't, 1 year, 2 years later, doesn't run. And so this happens. So there's a number of ways that you might approach solving this problem. One thing that was discussed very extensively in R-devel a couple months ago was, well, one way we could do this would be, there's an R release once a year, and upon a release of R, we can freeze all of CRAN. So we'd say R3.1 is out, all of CRAN And my code will never break this. There'll always be this one release of R, R3.1, R plus CRAN. And there's some attraction to this because it's very simple. Users don't have to do anything new. They just say, well, I use R3.1 and all the things from CRAN, and my stuff will always work. But it's unfortunately, so it's simple, but I think it's an incomplete and an inflexible solution. So I think we probably need to do better than that. Think about, what if we actually say, okay, CRAN is frozen. That's how things work. Well, that would solve part of the problem, but you've got lots of other places that packages might come from. There's other repositories, there's RForge, there's Bioconductor, there's development versions of packages. People install a lot of packages from GitHub now. They just install them directly from RForge. People have internal in-house packages that aren't distributed on any repository. And so there's lots of places that packages come from, but there's also, one of the problems is it's very nice to say, well, we'll freeze CRAN and everyone will be happy with that. But what happens is inevitably users will say, well, there's a bug fix I really need. I have to have this bug, I have to have this new feature, I have to, you know. And so it's a very leaky kind of system because users will always push to have something more recent. And so we've got CRAN frozen, and we've solved part of the problem. We've got lots of things, unsolved problems, but you know, a frozen CRAN would not have, as I said, bug fixes delivered in a timely fashion. It wouldn't have a lot of what we like about R, is that it's very dynamic, very vital. New things are coming out all the time. New analytic methods are coming out all the time. New ways to publish and share things are coming out all the time. And you'd also have this sort of, well, I've got to keep upgrading the new R to get new packages. So in order to go to R, in order to get the new version of Plier, I need to go to R3.2, or in order to get the new version of RCPP, I need to go to the next version of R. And so I think that you don't need to belabor this, but one point is, you know, updates to things on CRAN are probably more likely to fix a bug or fix compatibility problem than they are to introduce a problem. You know, it's probably better that people keep getting new things from CRAN than worse. And I think because of this, people are just, if you try to freeze CRAN, people are just going to find ways around it, and you're going to be back in the same sort of system of where did all these packages come from, how can I reproduce things. So I don't think that's an answer. I do think freezing is the answer. You do need to in some way freeze what you did. I did this analysis, it ran, it completed, it's how I want it to be, I need to freeze it. I think what you really need to do is, rather than freezing a repository, one or more repositories, you have to be able to freeze a project. This project, I now can, I want to know that I can reproduce this project with this code. And really, it comes down to taking arbitrary combinations of R packages and basically be guaranteed that I can run those packages in the future. So this is not a new problem in software environments. Most environments, I have some examples from Ruby, JavaScript, and Python. They have some concept of, you know, right now you have a global, you know, user library in R. They have a notion of, well, for each project I have a library, and that project gets its own library with its own versions of packages. Some way to specify versions that I want in that library. I want this version of ggplot, not that version of ggplot. And then an ability to sort of bring the library back when I need to deploy. So this has been done in lots of other environments. It hasn't really been done yet in R. And I think one of the issues is, you know, these environments are typically built for software developers, and so there's still a lot of tending to them that has to be done. You know, editing files that specify dependencies. And I don't think the R community, by and large, most R users don't say I'm a software developer. They say I'm an analyst or a scientist. They don't want to be bothered with lots and lots of configuration management tooling. And so we want to create a solution that's very automated as well for our users. It has flexibility. It has the same granularity and flexibility other systems has, but it's possible to work in a very automated way. So I want to talk about Packrat. This is actually, it's an R package that implements a dependency management system for R. Right now it's on GitHub, and that's the URL. I'll post that again later. And we'll submit it to CRAN later this year. So fundamentally, what is Packrat? One is it creates a private package library for any given R project. You can think of an R project as just a working directory. So for a given data analysis or a given paper, you have your own package library. There's a function, there's really two fundamental functions in Packrat. One is snapshot, which says record all the packages I'm using, the versions of those packages, and download the source code of those. So capture all the source code for all the packages I'm using so I can reconstitute it. And then restore says take what I've snapshotted and bring it back to life. So it could be 5 years later, I want to bring this analysis back, I do a restore. It could be I deploy to a server, I want to do a restore. It could be me and a colleague are working together and they can restore and make sure they're using all the same versions of all the packages. Those are like the sort of the fundamental verbs that are in play. And they're reflected as R functions, which I sort of just described. They're sort of, I want to use Packrat init, capture the packages I'm using and their source code, and then restore. I brought my analysis to a new machine, reconstitute my library just as it was on the original machine. And so this is sort of, I'm going to initialize, I'll just show you sort of what it would look like. I'm going to initialize a project. It starts you off with the Packrat package. You always have to add an name to the Packrat project. And then and this is an example where I'm using I'm just using the reshape2 package. And so when I do a snapshot, it says, oh, I see that reshape2 depends on apply RCPP and string R. It actually goes and gets the source code for each of those packages, saves the source code, and saves all the versions of the packages that you're using. So at the point at which you've done a snapshot, you can now, at any point in the future, or on any other machine, get your project back to exactly the state that it was in when you snapshotted. And that's what it would look like if you went to another machine and you did a restore. You didn't have all those libraries. Here it's going to restore them. In this case, it's just going to download binaries from CRAN. But if it needed to build packages from source, if they weren't on CRAN, they were GitHub packages, they were RForge packages, it would build them from source. Or they were concurrent versions. You know, it's RCPP 11.2 and we're already on to RCPP 13. It would go to CRAN, or that wouldn't need to go to CRAN. It would have the source code for RCPP 11.2. It would build it from source, and you'd be good to go. Here's an example of, oh, there's a bug in RCPP that I need a fix for. And it's on GitHub master, right? It's been fixed. I have it. We're going out with this thing tomorrow. You know, something's crashing, or something's random number generator isn't working correctly, or what have you. So I need to get a fix for this. So I go and install RCPP master from GitHub, and then I retake my snapshot. It says, oh great, you just upgraded from the version from CRAN to a development version. We save the source code for that. And then similarly, when I go to restore that later, I'm going to build RCPP from source. There is no binary for that. That's a GitHub development version. There is no binary for it, so we build it from source. So that's the basic workflow. It's snapshotting and restoring. And you know, you can use it in a really simple way, which is, I just do my work, I do my analysis, I'm all finished, I've delivered my work to the end customer, you know, created my paper, created my report. I'll just go Packrat snapshot, and be done with it. Now I've just frozen that. You don't need to interact with this as you work. You can just say at the very end, I just want to make sure I can reproduce this. And then restore you use later, or a colleague would use it. We have a utility that would sort of automate this further, which is to say bundle. So it's like basically take this project, make sure I have all the source code, put it in a tarball, and save it. So now I've got a single tarball that has all my code, all the package source code, and then anybody who wants can unbundle that, and it will again get all the code. Here you can see it built RCPP from source. Today we've got a GitHub version of RCPP. It downloaded binaries from CRAN. 3 years from now, there might not be binaries on CRAN, so in that case, it will build these from source. So that's sort of bundle and unbundle, which is another high-level operation. And the goal here is, if you look at Packrat more carefully, there is a lot of granularity to it. It does work in a similar way to Ruby bundler or Python virtual env, but we're trying to give sort of a one-button, there is one-button operation that's possible. Bundle, unbundle, snapshot, restore. So you don't get mired down in all the details and semantics of configuration management. This is sort of what does it mean when you add Packrat to a project. Basically, it writes an R profile into your project directory that sort of initializes Packrat. It has a private library for your project. That's where all your packages go. Saves the source code for your packages. This lists all the package versions that were used, that's packrat.lock, and then there's some options. So there's really just a Packrat directory that exists in your project and an R profile that's added to your Packrat is designed to, it does not require version control, but it's designed to work with version control. So that Packrat lock file is a text file that basically records all the versions of things. So for example, I can see, oh, you know, I went and upgraded to RCPP master from GitHub, and that's in version control. So someone else can say, you know what, we don't do that here. I'm sorry, you need to work around that bug. We don't allow that. They can revert that. So you have if you're using version control, you can see every change to your configuration that's made. You can revert them. It's not required again, but it's because all of the side effects of Packrat are you know, text files. You can diff them. You can manage them in version control, etc. So sort of recapping what Packrat's about, really trying to capture everything required to reproduce your project or your configuration. This does not require any changes to CRAN or the way CRAN works. It works with CRAN as it is, and it works with arbitrary other repositories, including, you know, just its local source packages. And again, the concept is let's make it flexible, let's make it very easy to use for our users. So one button operation, whether it's snapshot, restore, or bundle, unbundle, and make it work with version control. So that's kind of at a high level what Packrat's about. There's a lot more to it, but I just want to give people the overall concept of the project. There's a website that explains some of this in more detail, has more examples. That's the first link, and then there's the source code for Packrat is available on GitHub as well. So with that, we do questions in line with each talk. Probably is the most sensible thing. So, what questions do people have about this?
Okay, so thanks for the talk. Yeah, other questions?
You said it was all kinds of repositories.
Yeah.
How would Packrat know where the source comes from?
It's a good question. So right now, I think it's what I more meant to say is in principle it works with all types of repositories. So we know when a package comes from CRAN. We know when a package comes from Bioconductor. We know when a package comes from GitHub. So there are tells or signatures in the description files for those packages. Joe, do you remember do we know about RForge right now, or?
No, I think I can have a view right now.
Okay, so right now but for example, the way the GitHub works is it writes the username, the repo, and the SHA-1 of the, you know, so that can be done with Gatorius and other things, just the same.
If a recent enough version of DevTools was used?
I think so. I think
but DevTools has a hook for the other things. I mean, DevTools has installed _Gatorius.
It has, yeah. I think they're hooked up to save the SHA-1s now. I think, I'm not positive. And someone just put in a pull request. I don't know if it's taken yet to DevTools to do install SVN. So it's installing from SVN repos. And again, if there's a tell in the description file, then we know what it came from.
One thing that always bothered me with CRAN repositories is that only the latest version is actually in the repository. The other ones are shifted to the archives.
Archive, yes.
So is there any functionality included in Packrat that would allow you to rebuild an own library that is independent of your projects that you can call on instead of from
Oh, I see. So you want to create a project. It's interesting. You want to create a library that's not really tied to a project per se, but it's just a library, right?
It's a meta bundle, if you want.
Right, it's a meta bundle. It's based, you know, I guess you could, it's all based on working within a scope. So,
Okay.
so you could have a scope called My Projects, and you could Packrat label that scope, and you say, well, I always work in that scope. The problem is that if you further divide that scope into other working directories, typically you start R in a working directory, and it reads the profile from that working directory. So
Okay.
I don't know how well that would work. You could do it, but it might inconvenience you in other ways.
Okay.
Okay, so I had a use case with a big financial company here in Germany. they spend a lot of work evaluating R packages,
Okay.
and then they have a team which says, okay, this version is stable, you're allowed to use this for some creating reports.
Yes.
Versions above that are not approved, you're not allowed to use them.
Right.
And they want to set up some kind of global rule so that people can use this version but not the higher versions. Is there anything, any
Would
good
they
tip
want
from
to,
your
Dirk
side?
might know, would they set up their own repo for that, basically? Their own CRAN-like repo for that?
Yeah.
Maybe.
Would be a chance, but sounds like a little bit of extra work around that, so would be there a chance to deal with Packrat?
This is much more concerned with what did you use? We're not trying to control what you use. What did you, in fact, use? And then reconstituting that. I think, though, I mean, Joe, you could edit the lock file directly and say, we want to, make sure your lock file has these versions in it. You could create a template, but I still think there's manual.
At the very least, if people are using Packrat on their projects, then you at least have this metadata that's captured in the source code repository. So, for example, the organization could write a script that scans the repos they know about and just make sure that everybody is using approved version. That'd be much easier.
Right, you can audit, you can start with this, there's no other way, like, versions of packages do not get recorded in version control if you don't use something like this, so they're just sitting on everyone's machine. So you said you at least would have audit over that.
If packages in the past were built from source, would it make sense to also record which compiler version was used to do that? Could that introduce something change?
Well, interestingly, yeah. Because you might be rebuilding with, obviously, you're rebuilding with GCC 4.9, or you're rebuilding with Clang. And that is a dimension of things, right? They could handle floating point differently.
Yeah, I mean, you have so many change things. There's so many things that can change. I mean, when you were just sniping really, these packages change, whatever. Sure, they do, but that was willing, right? It did us a We just broke because we wanted to do it better. I mean, I was just working on something sort of with some RStudio perspective. And there's an archive package on CRAN from 2000. I remember looking at them when I first started. There was something that Kurt tried. It's still there because it's archived. It's a minimal C++ source code, and it almost still builds. It's not sort of these two things because two C++ changes happen. So we now want IOStream and not IOStream.h.
Yeah.
And we now have to use a namespace, which was implicit back then. And it's just about the same changes on the R side. You now have to add a maintainer field, which the description file didn't have, and you have to provide a namespace file. But it's 2+2 minimal changes over 4.
And then so that breaks that.
But it's on 29 of source code or something like that. It's really hard.
So there's no thing infallible. I think this gives you like one next layer of reproducibility, but it doesn't. Another way to do it is save everything in a virtual machine, a big binary virtual machine. And there's people who think that's a good answer, and it might be for some cases. It's very heavyweight. Another thought that I think Dirk's going to talk about this a little bit. Is you could create use Linux containers or Docker, if you've heard of that, to basically say, well, I actually want to freeze not only R, but I want to get Ubuntu 12.04 and the versions of all of the compilers and everything. I want to be able to run that again in 5 years. And that, again, with more work, with more bother, higher fidelity.
I have a question in line with Marcus' question. Is there kind of a sandbox facility to systematically try to update your Packrat bundle to test if a new version of one of the packages you included still works in line with all your packages?
Yeah, we talked about that. That's something that some other systems like Movies Bundler will do that kind of thing for you. It's much harder right now for R because these repositories, like you said, CRAN only maintains the metadata for what's on the tip. And so, for example, if you want to interrogate all the versions in between, you have to download all of those packages.
Exactly.
So right now we don't have a solution for that, but you could certainly imagine in the future, writing some software around CRAN to maintain a metadata of that kind of, a database of that kind of metadata, variable, and things like that. And then the same thing with GitHub. I'm really excited about that idea.
So are you planning on implementing that within Packrat, or is that something really far off?
I think what we're hoping, again, we haven't talked much about Packrat. We actually, I didn't show any of this, but we we've added a bunch of tooling into the IDE to make it really easy to use, and we're gonna even inside the IDE you'll see a Packrat button and the packages tab. So we're gonna hope that lots of people use this and get hooked on it and love it, and that will drive us to invest in it. You know,
Okay.
if people are really using it and they're saying, what about this, and what about that, and what about sandboxing it, then we'll, you know.
Well, I think it's fantastic. I've been trying to come up with a similar idea for the last 3 years to get my workflow going, but you should have been come out. It's really
so
good.
if you, the latest version of the public RStudio IDE, and then it has some, you'll see, I didn't show it again, but it has some things to support using Packrat.
Okay.
And then this latest version. And then we're actually on we're going to keep working on it over the next 2 to 3 or 4 weeks. We're going to keep making that better, and then at some point we'll sort of announce to everyone, hey, you should really look at this.
Great.
It's a little early to start blaring the horns, like everybody look at this. So we're getting close. So.
All right.
Okay, I think that's a great point to move the rest of the discussion to the offline time. So thanks again.